Welcome to Maths and Engineering by IITIAN channel. In this lecture, I will be continuing with the quadratic equations problems and I will be explaining different concepts along with solving the problems so that you can get the grasp of the concepts which will be very useful. This is for regarding the quadratic equations in algebra. These lectures will be useful for Quantitative Aptitude, GRE, GMAT, SAT Mathematics and also CBSE Mathematics, IIT JEE Mathematics, and also for Bank PO examination and Bank examination, Quantitative Aptitude examinations. I am dealing with quadratic equations. For example, I have taken an example, very good example, from which you will get the concepts of quadratic equations and the solutions. Real roots, complex roots. Let us say one quadratic equation is there, x² plus px plus q is equal to 0. We have to find out the number of pairs of p and q in the above equation, so that the above quadratic equation does not have real roots. No real roots. Real numbers I have already explained, minus infinity to plus infinity, and if there are no real roots, what will be the value of p and q? At the same time, another condition is there, p and q are prime numbers less than 100. You know what is the prime number? Prime number is the number which is divisible by itself and 1 only and not by any other number. That is called the prime number. For example, 3. It is divisible by 3 only. It cannot be divisible by any other number. Like 7. It is a prime number. 11 is a prime number. I am only giving the examples. Now we have to find out the number of prime numbers less than 100 for p and q such that the equation x² plus px plus q is equal to 0 does not have real roots. It's a very good example on quadratic equations. Please pay attention to the concepts involved in it and let us try to solve it. Here, what is the question given? Find the number of possible pairs of p and q such that p, q are prime numbers less than 100 and they satisfy the equation x² plus px plus q is equal to 0 and this equation does not have real roots. Roots are different and p and q are different. P and q are part of the equation. Please note that distinction. Let us try to find out the solution. If ax square plus bx plus c is equal to 0 represented a quadratic equation, a general quadratic equation, then discriminant of it is equal to b square minus 4ac. Here, if discriminant, this is equal to d. If D is less than 0, it implies the equation does not have real roots. This is the concept from quadratic equations. Now, here the condition is, here it is x square, sorry, we will change the color of the pen, x square plus px plus q is equal to 0, let it be compared with ax square plus bx plus c is equal to 0. These two implies for no real roots, that means for real roots not to be present, no real roots, d is less than 0, that means b square minus 4ac is less than 0, that is b square is less than 4ac for no real roots. No real roots. Now, what is b square here? B is equal to P and C is equal to Q and A is equal to 1. That implies A is equal to 1, B is equal to P, C is equal to Q. B square minus 4, B square is P square is less than, this implies P square is less than 4 into what is A? 1, C is Q. That means P square is less than 4Q. When you change the left hand side to right hand side, then automatically the inequality also changes. That means 4Q is greater than P square. That implies Q is greater than P square by 4. This is the condition what we have got from the given equation. We are supposed to find P and Q values, not the inequality. We have to find out P and Q such that PQ are primes less than 100. Q should be less than 100. And it should be a prime. And P should be less than 100 and it should be a prime. That is the condition. Now let us try to find out the choices. How many ordered pairs? P square is less than 4Q. Let us use this one. What are the conditions given? Given conditions are, please pay attention to every step. Given conditions are 1. P is less than 100 and a prime. 2. Q is less than 100 and a prime. And third, most important, from the equation P square is less than 4Q. And P and Q are prime. Let us say, what are the primes less than 100? Just think. 2 is the prime. 3 is the prime. 5 is the prime. 7 is the prime. 11 is the prime. 13 is the prime. 17 is the prime. 19 is the prime. 23 is the prime, and so on, up to 97. Let us say P is equal to 2. P is equal to 2 satisfies the condition that P is less than 100 and it's a prime. That implies P square is equal to 4. P square is less than 4q for no real roots. That's what we have got here. Please try to understand. For example, P is equal to 2, which implies 4 is less than 4q. That implies 1 is less than q. That implies q is greater than 1. Any value greater than 1 will be a pair for P is equal to. That implies 2, 3, 5, 7, 11, 13, 17, 19, 23 up to less than 100, that is up to 97, because this condition also we have to fulfill. That means if P is equal to 2, Q is equal to all the primes up to 100. This number comes to 25 pairs, 25 numbers, 25 primes. Please try to understand this. Next P value can be P is equal to 3. P square is equal to 9. That implies 9 should be less than 4q. That implies q is greater than 9 by 4. That means q is greater than 2.25, that is greater than 2. Then q greater than 2 means you remove 2 from above. Answers will be 3, 5, 7 up to 97. How many primes? Here, because only 2 is taken out, 24 primes. Now, P is equal to 5. That implies P square is equal to 25. That implies 25 is less than 4q. That implies q is greater than 25 by 4. That means q is greater than 6 in integers. Any integer greater than 6 and a prime is, you will be taking out 2, 3, 5. From 7 onwards, 3 will be taken out. Q greater than 6 to be prime is 7, 11, 13 up to 97. How many primes will be there? From original 25, we have taken out 2, 3, 5. 3 we have taken out. That means 22 primes, sorry. 25 minus 3 is 22 primes. Now, it looks a little bit cumbersome, but you will be able to do it, this type of problems, once you are accustomed to it. P is equal to 7. What is P square? 49. That implies 49 is less than 4q. That means q is less than 49 by 4. That means q is greater than, that means q is greater than 12.5. That means q is greater than 12. The prime. After 12, the prime is 13, 17 up to 97. How many are there up to 13? If you remember, remove 1, 2, 3, 4, 5. 5 you remove from 25. Then this will be 20 pairs, 20 primes. Please see how beautiful the question is. I made it on myself. P is equal to next 11. That means P square is equal to 121. That means 121 is less than 4q. That implies q is greater than 121 by 4. That implies 4 30s are 120. That means greater than 30. Q is greater than 30 and should be a prime. After 30, what are the primes? 31 is a prime, 37 is a prime, and go on, so on up to 97. Up to 31, if you remember, if you remove, after 23, it is 29, 31, and so on. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 you have to remove. That means there are 15 primes. Similarly, as a homework, please do for others. When P is equal to 13, P square is equal to 169 implies 169 is less than 4q. That implies q is greater than 169 by 4. That implies q is greater than 40. That implies there are how many? 12 primes. Please check it. It is homework for you. Please do. Mathematics, if you do only, you will learn. Have done much, you do the remaining. P is equal to 17. P square is equal to 289. That implies 289 is less than 4q. That is, q is greater than 289 by 4. That implies 72. Q is greater than 72. That implies how many? There will be 5 primes. These you please check from your basics which I have taught you. Then P is equal to 19. That implies P square is equal to 19 into 19 will be how much? Just check up. 19 square. 19 into 19, 361. That implies 361 is less than 4q. That implies q is greater than 361 by 4. That implies q is greater than 90. That implies up to 100. How many primes are there between 90 and 100? Because it should be less than 100, that is 99. 90 and 99, only one prime is there, 91. That implies, or not 91, it is 97. 1 prime. Hence, If P is equal to 20, P square is equal to 400. That implies 400 is less than 4Q. That implies Q is greater than 400 by 4. That implies Q is greater than 100. Not acceptable. Because condition is that Q should be, since Q should be less than 100. Hence, we will stop the iteration here. And this is not acceptable. P, maximum P value should be 19. Here how many? How many primes? Total pairs are? Total pairs will be 25 plus 24 plus 22, 25 plus 24 plus 22 plus 20 plus 15 plus 20 plus 15 plus 12 plus 5 plus 1. That is equal to 49, 71, 91, 106, 118 plus 6, 124. Answer is PQ pairs is equal to 124 pairs. 124 is the answer. I think you have got the meaning of it. Provided P and Q are primes less than 100. And x square plus px plus q is equal to 0 does not have real roots. And x square plus px plus q is equal to 0 does not have real roots. PQ is equal to 124 pairs. With this, I want to conclude this lecture. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. This type of questions I will be developing on my own and giving it to you and explaining the concepts recurrently. Explanation of the concepts and revision of the concepts will definitely give you some confidence, and with that confidence, if you sit in the examination, you may be able to score high. Please clear the concepts rather than only concentrating on the answers. Once your concepts are cleared, you can answer any type of question. Best of luck. Thank you for listening to me. If you feel there is a value addition to your knowledge with this video, kindly share and subscribe to my channel Maths and Engineering by IITIAN. Thank you. Best of luck to everybody.